I saw a video on the Radio TechCon channel last week in which audio consultant Rupert Brunn gave a fantastic presentation on the BBC's pips. I'm sure you know what I'm referring to, but if you don't, these are the pips. He had 5 minutes to present a potted history and delivered it with punch and lots of humour in 9, and I'll link it below. The presentation actually took place in 2024 when the pips turned 100. As I have more than 5 minutes and more than 9, I thought why not make my own presentation on the pips. The famous Greenwich time signal pips, once as much a part of the English way of life as cricket and roast beef and Yorkshire pudding, were the brainchild of 9th Astronomer Royal Sir Frank Dyson and the head of the BBC John Reith, who commissioned Marconi Siemens in Charlton, close to Greenwich, to create the signal. The pips first sounded on the 5th of February 1924 at 9:30 p.m. They've been broadcast daily since and were originally controlled by mechanical clocks located in the Royal Greenwich Observatory that had electrical contacts attached to their pendula. Multiple clocks were used in case of a breakdown of one. These sent a signal each second to the BBC, which converted them to the audible oscillatory tone broadcast. Pip went the loudspeaker, and millions of watches and clocks all over the country were adjusted. Broadcasting of the Greenwich time signal pips was a service which all the listeners agreed was useful. Greenwich Mean Time is a measure of the angular position of the Earth about its axis of rotation. It is determined by observation of stars as they transit the observer's meridian, corrected for the observer's longitude with reference to Greenwich. It's been known for many years that the rate of rotation of the Earth is subject to irregular and unpredictable variations, but the effects are too small to be noticeable to all but the most precise users. Time signals are used to disseminate Greenwich Mean Time to the general public, the navigator, the surveyor, and the space scientist. For many scientific purposes, a uniform timescale is of paramount importance, but why were 6 pips given, and how could the signal be broadcast at odd quarter-hour intervals? There are 6 pips, or short beeps in total, which occur on each of the 5 seconds leading up to the hour and on the hour itself. Each pip is a 1 kHz tone, about a fifth of a semitone above musical B5, the first 5 of which last a tenth of a second each, while the final pip lasts half a second. The actual moment when the hour changes, the on-time marker, is at the very beginning of the last pip. In mid-1928, an experiment was undertaken in which 4 tuning forks of the scale C major were sounded simultaneously by electrical contact just before the pips. Why, I'm not sure. At Greenwich there were 3 clocks kept in a cellar once used for wine. By 1930 they were named Short 3, Short 11 and Short 16. They changed numerous times before and after 1930, but this is just an example. Short 3 was the standard timekeeper. Short 11 was kept as a standby in case of emergency, and Short 16 was connected up for broadcasting the familiar pips. Basically, a mean solar clock, corrected by clocks, which in turn were corrected by the stars, carrying a small toothed wheel which made 6 signal contacts every quarter of an hour. The switch in contact with this wheel was linked up to the GPO landlines, and every quarter of an hour, 6 impulses were transmitted by wire to all parts of the country. The BBC received these impulses and amplified them. The pips had a set 1 second interval. They gave seconds 55, 56, 57, 58, 59, and the exact 60 of the minute. They were tested in 1930, and in just over 5 years, the clocks had varied less than 0.005 of a second a day, allowing for periodic calibration. In those days, the station at Daventry, call sign 5XX, broadcast the most time signals. At 10:15 a.m. there was a relay of Big Ben, and at 10:30 there was a Greenwich Mean Time signal, except on Saturdays where there was a Big Ben relay at noon, and there were further Greenwich time signals at 10 p.m, 4:15 p.m, 6:30 p.m, 9 p.m, and 10:30 p.m. The Greenwich signal on Daventry's 5XX frequency was compulsory, and it was always broadcast, even if it meant its superimposition on music or any other part of a programme. As newer state-of-the-art transmitting stations were built up and down the UK, they adopted the transmission of the time signal, Rugby being a notable station. Hubris, perhaps, possibly, leads us to believe that the pips have rarely encountered technical difficulties. 1 or 2 instances from the 2000s are widely reported. Big Ben was one up on Greenwich on the night of September the 21st, 1933, when the BBC found they were unable to broadcast the 6 pips of the Greenwich time signal at 6 p.m, so they called on the chimes of Big Ben to tell listeners the right time. An official at the Royal Observatory stated that their clocks were working regularly and that the 6 pips left Greenwich by way of landline to Broadcasting House. The BBC would give no information except to plead that the missing time signal was due to causes beyond their control. At 9 o'clock, the Greenwich pips were again not broadcast. It was later discovered that the special landline between Greenwich Observatory and the BBC was to blame. This was the first time there had been a failure on the line. In another instance in 1935, 5 pips were broadcast instead of 6. The BBC was inundated with hundreds of complaints from listeners who wanted an explanation. They also wanted to know which of the 6 pips was missing. The BBC later confirmed it was number 6. After D-Day and for the rest of the Second World War, the familiar 6 pips synchronised artillery barrages on the Western Front. At the request of Field Marshal Montgomery, the signals were radiated every hour, day and night on certain services, and artillerymen set their battery watches by them. After radio newsreel on the BBC's Light programme on the evening of the 22nd of October 1948, the announcer apologised for the pips going astray at 7 o'clock. He then said, "It's now 7:30, you'll hear them now." There was a silence, and again the announcer apologised and said that the pips had once more been mislaid, but would be given later in the evening. On March 2nd, 1949, a broadcast announcer broke into the programme to say that the 1 p.m. signal had been 7 seconds fast. It was repeated at 1:30 p.m. correctly. Of course, Greenwich didn't always record Greenwich Mean Time. In fact, the electric clock built into the wall of the old observatory building in Greenwich Park was, by the 1950s, invariably between 4 and 5 minutes slow. The reasons for this were obscure, but there was nothing obscure about the views of thousands of visitors to the old observatory who still set their watches by the old clock. The pips were as right as could be, however. The Royal Greenwich Observatory moved to Hurstmonceux Castle in 1957, becoming the new Royal Greenwich Observatory, or RGO. The Greenwich site was renamed the Old Royal Observatory. The Greenwich time signal equipment followed a few years later in the form of an electronic clock. Reliability was improved by renting 2 lines for the service between Hurstmonceux and the BBC, with a changeover between the two at Broadcasting House if the main line became disconnected. The tone sent on the lines was inverted. The signal sent to the BBC was a steady 1 kHz tone when no pip was required, and no tone when a pip should be sounded. This let faults on the line be detected immediately by automated monitoring for loss of audio. Because the signal travelled from Hurstmonceux on a landline, they were sent a fraction early so that they were broadcast at the right moment. The pips were also broadcast by the BBC television service, but this practice was discontinued by the 1960s. On September 3rd, 1965, fuses at Hurstmonceux were blown by lightning. Because of this, the pips weren't heard before the 6 p.m. BBC Home Service radio news bulletin. The clocks at Hurstmonceux were replaced in 1967. The heart of the equipment was a very precise cesium atomic clock, which was used to generate an extremely stable and accurate high-frequency signal. By the late 1960s, international time signals were broadcast on an interim compromise system, which gave Greenwich Mean Time to 1/10 of a second accuracy. This had provided a uniform timescale for the past decade. In 1967, the 13th General Conference of Weights and Measures defined the time interval of 1 second in terms of a particular atomic transition to an accuracy of 1 part in 10. Since that date, the second was no longer equal to 1 in 86,400 of a mean solar day. The 14th General Conference of Weights and Measures in Paris in October 1971 endorsed the International Atomic Timescale established by the Bureau International de l'Heure. By international agreement, and commencing with the new year, radio time signals would be broadcast in conformity with the International Atomic Timescale, in which the time interval corresponds exactly to the second as defined by the atomic transition. The rate of rotation of the Earth at present was such that at the end of the year, the new broadcast timescale would have gained 1 second relative to the Earth. In order that the broadcast time signals should not depart from Greenwich Mean Time by much more than half a second, the time signals would be adjusted by the introduction of a leap second when necessary. For example, if the Earth continued rotating at its present rate, it would be necessary to delay the broadcast signals by inserting a positive leap second at about the end of June 1972. For convenience, it was decided to introduce leap seconds when necessary on the last second of the month, preferably December the 31st and or June the 30th. In the case of a positive leap second, 23 hours 59 minutes and 60 seconds would be followed 1 second later by 0 hours 0 minutes and 0 seconds of the first day of the month. In the case of a negative leap second, 23 hours 59 minutes and 59 seconds would be followed 1 second later by 0 hours 0 minutes and 0 seconds of the first day of the month. The BBC 6 pips time signal conformed to the new system. With the introduction of the new broadcast time system, it was decided to modify the signal slightly. Now the 6 pips would consist of 5 short pips from second 55 to second 59, followed by a lengthened pip, the start of which marked the exact minute. In 1986, outrage swept the nation. Well, maybe that's a bit too far, but there were plans slated to, quote, give the pips a foreign accent. My research led me nowhere on this for quite a while, but I managed to get to the bottom of it. Basically, the clocks were becoming old and reaching the end of their service life. Proposals to use German or Japanese to mark the top of the hour would have led to a voice-based countdown by an automated voice with a German or Japanese accent. Time stood still in 1989 while equipment at Rugby radio station was being rebuilt. For almost 40 years, the Greenwich time signal had been sent out on the airwaves from Rugby, but for 2 weeks the station was silent. From August the 1st to the 15th, the continuous signal was off the air, while major rebuilding of a worn-out transmitter cubicle was conducted. From 1990, the pips were generated by the BBC in London using their own equipment, after the Royal Greenwich Observatory moved from Hurstmonceux to Cambridge the same year. The pips were sounded for the last time by the Royal Greenwich Observatory on February the 5th, 1990, when the BBC took over the task. The old system relied on a landline between Hurstmonceux and London. The new signal transmitted direct from the basement of Broadcasting House and promised to be consistently accurate to within 1/1000th of a second. The new equipment to provide the service was based on 4 master clocks arranged in 2 pairs to form a main and standby set with automatic changeover. The clocks were linked by radio and satellite to international atomic time standards. One receiver was tuned to either Rugby or to Mannheim in Germany, while 2 others received information from satellites. The system was capable of an accuracy greater than 1 second in 4,000 years. The original pips could now be heard at the British Horological Institute at Upton Hall in Upton. It was transferred and set up at the Institute in summer 1990. The equipment was still functional, but being run for demonstration purposes only, and only the timekeeping was maintained. The BBC was taken to task by Carl Frederick Dolmetsch, an Anglo-French recorder player, when he noticed the pips had dropped from B natural to B flat. He monitored this for 2 weeks before writing to the BBC. They rectified the issue, but a year or so later they dropped back to B flat. He wrote to the BBC once again and became the subject of a documentary as part of the Arena Radio Night on Saturday the 18th of December 1992 on BBC 2 and Radio 4. BBC engineers confirmed that the problem was caused by a faulty signal generator. Due to its age, it had drifted slightly off frequency and was repaired by simply replacing resistors inside. At 8 AM on the 17th of September 2008, while John Humphreys presented the Today programme and Johnny Walker was standing in for Terry Wogan on Radio 2, the pips went adrift by 6 seconds and broadcast 7 pips rather than 6. This was traced to a problem with the pip generator, which was rectified by switching it on and off again. A complete failure in the generation of the audio pulses that constitute to the pips was experienced on the 31st of May 2011, and silence was unexpectedly broadcast in place of the 5 PM signal. The problem was traced to the power supply of the equipment, which converted the signal from the atomic clocks into an audible signal. Whilst repairs were underway, the BBC elected to broadcast silence in place of the pips at 7 PM. By 7:45 PM the same day, the power supply was repaired and the 8 PM pips were broadcast as normal. The The pips on national stations are still controlled by an atomic clock in the basement of Broadcasting House, which is synchronised with the National Physical Laboratory's time from MPL at Anthorn in Cumbria and GPS. On other stations, the pips are generated locally from a GPS synchronised clock. The broadcast pip's usefulness for time calibration is diminished by the time lags involved in digital broadcasting. The BBC compensates for the time delay in both broadcasting and receiving equipment, as well as the time for the actual transmission. The pips are timed so that they're accurately received on long wave as far as 160 km or 100 miles from the Greenwich AM transmitter, which is the distance to central London. Newer digital broadcasting methods have introduced even greater problems for the accuracy of the use of the pips. On digital platforms such as DVB, DAB, satellite and the internet, the pips, although generated accurately, are not heard by the listener exactly on the hour. The encoding and decoding of the digital signal causes a delay of usually between 2 and 8 seconds. In the case of satellite broadcasting, the travel time of the signal to and from the satellite adds about another 0.25 seconds. As for the future of the pips, the BBC aims to move to a computer-generated version consisting of a computer locked-to-precision time protocol. The pips are available to BBC radio stations every 15 minutes, but, except in rare cases, they're only broadcast on the hour, usually before news bulletins or news programmes. They're usually brought up on a fader. Normally, BBC Radio 4 broadcast the pips every hour except at 6 p.m. and midnight, at the start of the 6 o'clock news and midnight news respectively, and at 10 p.m. on Sundays, at the start of the Westminster hour, when they're replaced by the striking of Big Ben at the Palace of Westminster. On BBC Radio 2, the pips are broadcast at 7 a.m, 8 a.m. and 5 p.m. on weekdays, at 7 a.m. and 8 a.m. on Saturdays, and at 8 a.m. and 9 a.m. on Sundays. The BBC World Service broadcast the pips every hour. They were also heard on many BBC local radio stations until the introduction of a new presentation package in 2020. The BBC doesn't allow pips to be broadcast except as a time signal. It also discourages any other sound being broadcast at the same time as the pips, and doing so is commonly known as crashing the pips. Different BBC radio stations approach this differently. Radio 1 and Radio 2 generally take a relaxed approach to the pips, usually playing them over the closing seconds of a song or jingle bed, followed by their respective news jingles. Many BBC local radio stations also played the pips over the station's jingle before the 2020 rebrand. BBC Radio 4 is stricter, as it's an almost entirely speech-based network. So that's the history of the Greenwich time signal and the BBC pips. Any questions?